Alright, so here's another example for you about shear strain. So remember, shear strain is when we're looking at how an angle changes due to a deformation. So we have a thin rectangular polymer plate with corners P, Q, R, S. It has a width B of 400 millimeters, that's here. Height A is 180 millimeters, and it's shown in the figure. The plate is deformed so that corner Q is displaced. So it's corner Q over here, goes up by 3 millimeters, and corner R goes to the left by 3 millimeters as well. So we're supposed to find the shear strain at corner P. So what we have here, I've labeled this angle alpha. So that's an angle where, so we have our original 90-degree angle here, pi over 2. Then it rotates, you get this additional angle alpha, but it also rotates, so you have to subtract this angle beta. So to write this out, so corner P has a theta 1 equal to pi over 2, which equals 90 degrees. It then increases by the angle alpha and decreases by the angle beta. So we need to calculate alpha and beta and then find out what our theta 2 value. So theta 1 is pi over 2, and theta 2 is going to be this value. So that's theta 2. So we need to find the difference between pi over 2 and theta 2. Okay, so we have this equation. Well, first let's find angle alpha. So our final equation actually will be gamma equals pi over 2, our original angle, plus alpha minus beta. So that's, we're trying to find the angle of distortion, so we have to look at it like that. So first thing we do is calculate alpha. So alpha, we're going to use small angle theory, but it would be a sign where you would have this opposite dimension, 3 meters, over the adjacent dimension, 180 millimeters. So we don't actually have to write in sign, we can just, because the angle is so small, alpha equals 3 millimeters over 180 millimeters, and we get 0.01667 radians. Okay, next step, calculate what angle beta is. Again, we don't need to worry about here. We would be using tangent. We have opposite an adjacent but small angle theory lets us just say that beta equals 3 millimeters all over 400 millimeters, and we get 0.0075 radians. So now after deformation, we have that theta 2 equals pi over 2 plus alpha minus beta. So that equals pi over 2 plus 0.01667 minus 0.0075, and we get that theta 2 equals 1.579962 radians. Okay, then remember that gamma equals pi over 2, our original angle, minus theta 2. So that equals pi over 2 minus 1.579962. Sorry, this isn't gamma. This is theta 2. Sorry, everyone. Theta 2. And then gamma equals pi over 2 minus theta 2, so the change in the angle. And we get that that is equal to a negative equals a negative 0.000965 radians. This is a good place to use microradians, so we're going to multiply it times 10 to the 6th, and we get gamma equals negative 917 microradians. So it's negative because theta 1 is less than theta 2, therefore gamma is negative. All right.